Welcome back, everybody. This is the Vintage Sewing Machine Garage. You are watching a video about the Neki BU Supernova. This is the Supernova, not the Supernova Ultra. We'll talk about that machine in a different video. So you are looking at the motor that I wanted to get access to. So I loosened the bolts off the bracket, and we got the belt off. Went in and got the brush shaft caps off, and managed to get the remnants of the old brushes. I always check brushes on motors, and here is what was left of the brush. Was it still running? Yes, but this is the time. You know, I'm below 1/4 of an inch. It's time. That doesn't mean you can't keep using it, but I just wouldn't. Brushes are cheap. They normally are not that difficult to replace. Now this took more time. I had to, finagle the motor out of the machine. It's not as easy as those hung on the back, but it's not rocket science either. Okay, so, and again, just like you do with anything, make sure your machine and your motor are not plugged in. It sounds silly. That's common sense, but we all can sometimes forget. Now the commutator is this right here. This, and I'm just manually turning the pulley, the belt pulley, so you can see it moving, right? So the brushes, we have new brushes here, okay? I could have done this before putting the new brushes in, but I don't think it matters. Well, what happens is the carbon, as it comes off the brushes over time, you saw the carbon build up in one of the earlier videos of this motor, and the carbon will build up on the commutator. Now, when I first started overhauling machines, I would take the commutator and I would use garnet sandpaper, not sandpaper with aluminum oxide because that's metal. I would take garnet sandpaper and I would lightly sand to get the discoloration off and to make it shiny. Now, people will argue and say, well, you need to do that because you want to be sure that that you're getting good, current to the motor and not having any buildup. First of all, old electric motors work, and they work for many years like this. But in the interest of cleaning it, we're here. Let's go ahead and do it. I do think it will make a difference in the performance of the motor. Now, you will see people doing videos, some of them online, some of them are quite well done, where they will go and they will sand down, sometimes with a drill, sometimes with just their hands. They will sand this copper commutator down in order to get down to the shiny copper. Well, the problem with that is, and this is especially true with a motor like this because this is a proprietary motor. You need this motor or this kind of motor to make a Supernova run because of how it fits, because the Italians wanted this machine to be gorgeous. I think it is, but that was some of the compromise they made. So what's my point about sanding versus cleaning? When you sand a commutator, okay, the first thing we would do is we would disassemble the rest of the motor. We would take these two bolts out because here is the line right here. It's like a clamshell cover to the motor. Now the rivets for the tag are on one side. Sometimes I've had motors where the rivets were on both sides and they did not want the motor disassembled. You could tell because I went inside and disassembled it anyway, but it was a royal pain. This one I believe is fine because you can see the rivets are here, just two. There are, of course, with this motor you have these two very long bolts. These would come loose once this bracket's off. This shell would come off, and of course before any of that comes off, the pulley. There's a very tiny screw here that holds the pulley to the shaft. And if you're ever going to remove one of these pulleys, take a photograph or note where the drive shaft is in relation to the edge of the pulley. If it comes out or goes in, kind of measure it or get an estimate. Is it a 1/16 of an inch, an 1/8 of an inch, 1/4 of an inch even? Sometimes. If it's flush like this one, note this because when you take this pulley off of the drive shaft, you want it to be right back in the same spot. Now many of these drive shafts have a flat area where this little screw can kind of torque down onto, but you need to notice where on this pulley, where on the drive shaft the pulley is. Okay, so this one's flush. If I were taking it off, it would be going back to flush. That's something you want to note before you take it apart. Now, if I did that, I could take it apart and I could take the commutator. If I had the whole drive shaft out, we could do that, and I could even put some, a little bit of oil in the bushings, but I don't need to do that because I have access to the bushings here. So, why am I not sanding? I'm not sanding because copper is a soft metal, and when you sand copper, it's easy to remove a lot of it, and you will shorten the life of the commutator. There's only so much there. Now, these motors were built of very high quality, so there's still plenty of copper on there. This motor is not anywhere close to being worn out in terms of its copper. But if I sanded it, I could reduce the motor's life significantly. How much? I don't know. I don't really have a calculation for it. So what's my solution? I think I've mentioned this before in other videos. I take one of my cotton swabs, my 99% isopropyl alcohol, and I simply start very gently wiping. Now, look what's coming off here. The alcohol is pretty good at removing all sorts of things. If there's any old grease, there shouldn't be, but if there's any, it will come off along with the carbon. It's just, like I say, it's the black carbon coming off here, right? Now, normally, if the drive shaft is out of the motor, then we would be, you can either mount the drive shaft, and I've seen people use different techniques for getting the sandpaper around the commutator. But again, I want this commutator to last as long as possible. Okay, my wires here are actually in remarkable shape. If you have the wires of the motor, now you can't see all of them, but typically if a wire has started to go bad, there'll be a lot of times you'll see cracks and crumbling in the insulation. If you decide that you want to take the motor apart, again, you can, and in this case, it's not needed. If you did not have the ability to get the remnants of the old motor brushes out, you can also take this apart. When you take the motor apart and the drive shaft gets pulled out, then you can easily get rid of those old brush remnants. Be sure to get them out of there. Don't leave the brush remnants in the housing. You're going to have to pull them out. They should be easy to spot. Okay, so I'm going to take my finger and thumb on the pulley over here, the little belt pulley, and I'm just simply going to go around. Now you might think, oh, this is alcohol. Is it getting something wet? It is, but it's 99% isopropyl alcohol. Okay, it's a solvent, and that solvent is going to dry very quickly. Okay, so I'm not really worried, and I'm keeping it on the commutator, and it's not gonna harm the commutator. And you can see, again, you don't have to push hard. Let the alcohol do the work, and it's starting to soften that. And I'm just going around. You can even just hold the cotton swab there and just do this. Make sure your cotton swab's in good shape. Do not use a cotton swab that is shedding. Okay, you don't want cotton fibers in here. The alcohol, and again, as long as you don't snag a cotton swab, it should be okay. It's when you start snagging things that they get a little hairy, a little squirrely. So anyway, I'm just turning. Now, this is not as fast as, and I have a dry side here. I can also go in here and mop up some of that. I shouldn't say mop, there's not much alcohol on here. Now, you can see I'm still getting black off. You have to decide how much you think you should remove off of the commutator. Sometimes what you may discover is that eventually your cotton swab starts to not look very black anymore. It's starting to, it's just not pulling as much off, and yet you may see some staining here. Sometimes that carbon can work its way down in here, and it can actually get into the pores of the copper. And of course, you've got these little slots. Now, you will sometimes notice, guys, on YouTube videos, people will sometimes go in, or maybe you'll see it on a blog, and these little slots here, they fill up with carbon, and people will sometimes come across and try to dig out the carbon, and you can do that, but you really want to be careful here. Remember that copper is very soft. It's easy to damage it. It's easy to gouge it, and you don't want copper flakes flying around here because this is an electrical motor, right? So honestly, when it comes to motor performance, The first places in a commutator that fill up with carbon are these cracks. These motors were designed to work with them. Now, some of you may say, you may disagree. You may say, oh, no, 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 I want all the carbon out. And you can do that. And would it make any difference? Possibly. But I just don't know, exactly how much of a difference it would make. My take on this is I have had so many vintage sewing machines that could still sew really strongly, and their commutators had not been clean. Now, is this machine going to sew better because I've gotten all this black goop off? Yes. I think it's going to be more efficient. The motor's going to be stronger. But again, it's not going to take that long for the new brushes to start filling in those grooves. So I'm not going to take I'm not going to take any kind of very, it would have to be a very fine pick and try to claw out the carbon from there. Because to me, this is about balancing risk-benefit. Do I really want to damage the commutator just to get that extra bit of carbon out, which is really going to be, it's going to fill right back up, it's not going to take long. And honestly, look how shiny this is, guys. I'm still getting a little bit. Oh, by the way, make sure you're I'm turning this toward in the same direction it would go when it's running. Now, I'm still getting a little off, but it's getting better. Now, is this the same as if I had sanded it? No, and some people will sand and sand and sand until they see no black carbon. If you do that, you may remove a huge chunk of that very precious copper. And I say precious not because copper is super expensive, but because this is the commutator of a Necki Supernova motor. And what I'm trying to do is to preserve it. And you can see I'm still getting some of the black off here. And I'll just use this. This time I'll use the dry end. Make sure your cotton swabs are clean, right? You don't want dirty cotton swabs. It looks like actually I went through quite a few of them. You can see it's really up to you to decide how much of this carbon do you want to remove. You want to get most of it off, and I think I've managed to do that. Now I can still see some, right? Now you will notice sometimes people will look at the commutator because the brush typically seats somewhere around the center of it. Okay. All right, I've got, again, I can still keep pulling more off, but I've gotten a good 90% plus of this stuff built up is now off here, right? Now, people will sometimes I'm going to take a rounded end here. I don't want to scratch it. Well, it's not round enough for my, I want something that's going to be not sharp, okay? So, they will go from one, if you just take something here, go across the commutator, just a light feel, the more worn the commutator is, the more of a dip or an indentation you'll see in the middle where the brush has been contacting it. And I noticed that, there is some, but honestly, it's not that bad. If I go from one end to the other, it's worn some, and you would expect it from a 60-year-old machine, but it's actually in pretty good shape. So this is my take on this, guys. You can decide if you want to sand. Make sure you use garnet sandpaper, that red colored sandpaper. Don't use the aluminum oxide paper because then you're going to have aluminum dust in your motor, and you don't want that. Now, look at this. Okay, that's pretty darn clean. Sometimes they don't even come this clean. They're still a little more black. But when I know that now I'm not getting hardly anything off here anymore, what this tells me is this is clean enough. And to get it 90% cleaned without removing any of the copper, that is what you want, because you want this commutator to last. This commutator and this motor are approximately 60 plus years old, and it's not worn out. And I don't know how many more years of life it has. I suspect quite a few in terms of the commutator wear. But again, if you're one of the folks that really likes to sand them, and they do look nice when they're sanded, just keep in mind, you will be shortening the life of your motor. And if it's a generic motor, if it's a motor you can easily replace, you think, I don't care, I'll do it. And then when it needs a new commutator, I'll just replace the motor. There's nothing wrong with that if you can use a generic universal replacement. But these are specific. And I think I showed you guys in an earlier video. Remember, this motor has a different shape because it's going to be going, be careful with this, the motor is going into here, guys. Let's be helpful if I actually move the camera for you. See in here, you have these mechanical parts moving, these different arms. The motor is shaped to fit just so. Okay, it goes in one way like any motor, but it has enough room, but just enough. So if you try to put a different motor in here, now some of you may have, if you know of anyone who has, guys, let me know. I'd be very curious to hear of any replacements for this particular motor. This one is in sound condition. I'm actually very excited to have gotten the motor brushes replaced. We've cleaned the commutator. Before I run this motor, and while I have it out, it'll actually be easier, because if you want to lubricate the bushing, which I'm going to do, it's going to be awfully hard when the motor's installed and it's way back there. You're not going to be able to reach it. So while you have the motor out, let's go ahead and we'll put one drop, okay? Normal oiling for a bushing on a motor, and here's the other one, and they made it easy for us because it's red. I wish all of the companies had done that. Typically, when you oil the bushing of a motor, maybe once a year, and it's always one drop of oil. I will probably use 2 drops because this thing probably has, I'm just going to assume it has not been oiled in a long time, because obviously the motor hasn't been pulled out, if ever. It's possible this motor has never been pulled out of the machine. So I know the bushings are overdue, and I may give them 2 drops instead of 1. Why so little oil? Because there's not a lot of room in here, right? There's not a lot of space to put sewing machine oil. It's a tight spot, and so I'm looking forward to getting that done. That's basically part of there is no grease that goes here. That uses sewing machine oil as a lubricant for the bushing. A bushing is basically a cylinder collar that sits inside this little space here, and also on the other side, and then the steel drive shaft spins in that collar, that bushing. The bushings are sometimes made of brass or bronze, and but anyway, they require a couple of drops of, when you're overhauling them, a couple of drops of oil, and that's it, right? You're done. And so anyway, I'll be getting this oiled. Actually, let me just show you guys right quick before we go. I'll show you I think I've done this before on other motors, but why not? Now, remember guys, this is a good time to remind everyone, I think I mentioned this before, which is this. When you are going to put any kind of lubrication in a motor, whether it's grease or oil, there's only one specific place that it goes. Okay, because when you look at a motor, these motors vary, but a lot of times they'll have lots of openings and crevices on the end. You see this, this one, and then you have it on the other side, and that is to help. There's a little fan that spins on the shaft, and that's to help pull air to cool the motor. Never put oil anywhere. Never put it here. Don't put it anywhere except where it was meant to go. And in this case, and hopefully your Necky has this, there's one spot. Now, there's one hole here because gravity is going to pull it down. Okay, so I'm going to put, there's one, and I'm going to put one more. And a little bit dripped here, and I just got it with my thumb here. Okay, now I'm going to come over to the other side, going to do the same thing. And it occurred to me this time, I just put that one drop in here. Let's turn the pulley, if you guys can see. I'm going to turn the pulley, and the drive shaft is turning, and that should pull down, should help pull in some of that oil into the bushing. Okay, because remember, it's very tight. The space is very tight between the drive shaft and the bushing, and the oil is sitting there on top of the drive shaft because there's a little hole. So we want to pull it down, and then we'll get the other. I think you could probably just do one drop on each side, turn the pulley, and then do the second drops, right? And you can turn the pulley a little bit more there. Okay. All right. So now we've lubricated. We have lubricated the motor bushings. replaced the motor brushes, cleaned the motor commutator. Okay, now, and because of everything I can see so far, now we're only able to look so far into the motor. Okay, based on the commutator, I believe this will suffice in terms of servicing this motor. Again, we have the option if we want to take the whole motor apart. That doesn't have to happen on every single sewing machine that you get. You get an old machine, you want to make sure the motor's in good shape. Whether it needs to be pulled apart, that's really up to you. But that's not something that everyone does with every machine. It really depends on, is the motor running properly? Does it sound right? How old is the motor? Some of the motors go all the way back to the late 20s. And those motors you really want to pay extra attention to because they are that old. But there you go, guys. The Necchi Supernova from 1956-57, and we are getting the motor ready to be reassembled. I say reassembled. Basically, I have that little cap we're going to put back on here, and then we'll get this set in. I have inspected the belt. The belt looks great. So in the next video, I'll show you guys how I'm reinstalling the motor, and we'll put the belt back on. I've looked at the belt very closely, and when I say closely, I mean I take it up and I put my flashlight on it and I bend it and twist it looking for cracks. This is not an old orange belt that turned black. This belt was black to begin with. It's not the original, I know that. But even replacement belts go bad over time, right? They can dry rot. But I checked this one and it looks fantastic. So there's nothing wrong. You don't have to replace a belt just because you've gotten the machine. Who knows? Maybe the belt's been on there 2 years. I don't know. Because you don't have to take the motor out to put in a new belt. You just have to loosen it on the bracket like I showed in an earlier video. So, folks, I appreciate you watching me do this. I don't know how many videos there are on Ultras for things like motors, but I hope this was helpful. And in the future, we will be looking at different sewing machines. And some of you have asked about looking inside motors. We'll be taking some motors apart in the future. I'd like to find some candidates that would be good for that. So thanks for watching. I appreciate all of you tuning in. And let's see, I think, like I said, I've got one more video where we'll kind of put this back together, get it back into the machine, and then we're going to take a look at some of this dirty nastiness up here and see what we can come up with to get this incredible machine of incredible quality back together and sewing once again. Thanks for watching, everyone.